A statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of the top of the statue is 60 degree, and from the same point the angle of elevation of the top of the pedestal is 45 degree. Find the height of the pedestal. So, let us draw a figure based on this information. So, it is given there is a statue with the height 1.6 meter. It is on the pedestal. The statue is on the pedestal. And it is given angle of elevation of the top of the statue is 60 degree. This is the ground. From a point on the ground, the person is looking to the top of the statue at an angle of elevation of 60 degree. Let us draw it. And from the same point, the angle of elevation of top of the pedestal is 45 degree. From the same point, the person is looking to the top of the pedestal. This is the pedestal and this point is the top of the pedestal. The person is looking to the top of the pedestal at an angle of elevation of 45 degree. Always you remember you are marking the angle till the horizontal line. So, this is the pedestal, this one is the statue. A person is on the ground looking to the top of the statue at an angle of elevation of 60 degree and top of the pedestal at an angle of elevation of 45 degree. Let us give names for the point. I gave here A, B, C, D. This AB is the statue. It has height 1.6 meter. I marked here. Now let us draw the right triangles separately. The right triangles are triangle BCD with acute angle 45 degree and triangle ACD with acute angle 60 degree. The question is to find the height of the pedestal. Here the pedestal is BC. We need to find out the value of BC. Let us do the problem. Consider the first right triangle BCD with acute angle D with measurement 45 degree. For this acute angle D, BC is the opposite side and DC is the adjacent side. So, let us take the ratio. In triangle BCD, tan theta equal to opposite side by adjacent side. Here theta equal to 45 degree. Opposite side is BC. Adjacent side is DC. So, we can write tan 45 degree equal to BC by DC. We know tan 45 equal to 1. So, we can write 1 equal to BC by DC. Cross multiplying, we get DC equal to BC. Now, you consider the second right triangle ACD with the acute angle D with measurement 60 degree. For this acute angle D, AC is the opposite side and DC is the adjacent side. So let us take the ratio. In triangle ACD, tan theta equal to opposite side by adjacent side. Here theta equal to 60 degree. Opposite side is AC. Adjacent side is DC. So tan 60 degree equal to AC by DC. Tan 60 degree is root 3. So we get root 3 equal to AC by DC. Cross multiplying, we get AC equal to DC into root 3. Now you see the figure. What is this AC? AC is AB plus BC. AC equal to AB plus BC. So let us replace this AC by AB plus BC. That is AB plus BC equal to DC root 3. Now we know what is AB. It is 1.6. So we can write 1.6 plus BC equal to DC root 3. Now here we have proved DC equal to BC. So this BC we can replace by DC. That is 1.6 plus DC equal to DC root 3. Let us take this DC to right side. We get 1.6 equal to DC root 3 minus DC. Let us change the sides. We get DC root 3 minus DC equal to 1.6. DC you can see here common. We can take it outside. We get DC into root 3 minus 1 equal to 1.6. We can take this root 3 minus 1 to right side. Here in the left side it is multiplying with the DC. The right side we should have to divide it. So we get DC equal to 1.6 divided by root 3 minus 1. Now you can see that denominator is an irrational number. Let us rationalize it. How can we rationalize it? Here the denominator is root 3 minus 1. So we need to multiply it with root 3 plus 1 by root 3 plus 1. So we get 1.6 by root 3 minus 1 into root 3 plus 1 divided by root 3 plus 1. You see the denominator, it is of the form A minus B into A plus B. A minus B into A plus B equal to A square minus B square. So that is equal to 1.6 into root 3 plus 1 whole divided by root 3 square minus 1 square. That is equal to 1.6 into root 3 plus 1 whole divided by 3 minus 1. That is equal to 1.6 into root 3 plus 1 whole divided by 2. Now we can cancel this 1.6 and 2. We get that is equal to 0.8 into root 3 plus 1. That is DC equal to 0.8 into root 3 plus 1. The pedestal is BC. Here we proved DC equal to BC. So we can conclude height of the pedestal is 0.8 into root 3 plus 1 meter. Angle of elevation of top of a building from the foot of the tower is 30 degree and the angle of elevation of top of the tower from the foot of the building is 60 degree. If the tower is 50 meter high, find the height of the building. First, let us draw the figure based on this information. So, there is a building and a tower. The angle of elevation of top of the building from the foot of the tower is 30 degree. A person is standing here and looking to the top of the building at the angle of elevation of 30 degree. Then again given angle of elevation of top of the tower from the foot of the building is 60 degree. Looking to the top of the tower from the foot of the building at an angle of elevation of 60 degree. So there is a building and a tower. Looking to the top of the building from the foot of the tower at an angle of elevation of 30 degree. Looking to the top of the tower from the foot of the building at an angle of elevation of 60 degree. Now let us give the name for the points. So I gave names A, B, C, D. This is our tower. The tower is having height 50 meter. Now let us draw the right triangles separately. So the right triangles are triangle ABC, here with acute angle C with measurement 30 degree, and other one is triangle DCB, acute angle is B with measurement 60 degree. The question is to find the height of the building. Height of the building is AB. So we need to find out the value of AB. So let us do the problem. Consider the first right triangle ABC. Acute angle is C with measurement 30 degree. AB is the opposite side. BC is the adjacent side. Let us take the ratio. In triangle ABC, tan theta equal to opposite side by adjacent side. Here theta equal to 30 degree. Opposite side is AB, adjacent side is BC. Tan 30 degree equal to AB by BC. We know tan 30 is 1 by root 3. So we get 1 by root 3 equal to AB by BC. Cross multiplying, we get BC equal to AB root 3. Now consider the second triangle. Here the acute angle is 60 degree and this DC is the opposite side, BC is the adjacent side. Let us take the ratio. In triangle DCB, tan theta equal to opposite side by adjacent side. Here theta equal to 60 degree. Opposite side is DC, adjacent side is BC. Tan 60 degree equal to DC by BC. We know tan 60 degree is root 3 and DC is 50. So we get root 3 equal to 50 by BC. Cross multiplying, we get BC root 3 equal to 50. We can take the root 3 to right side. We get BC equal to 50 divided by root 3. Here we go to the value of BC. Here we have written BC equal to AB root 3. In this place, we can replace BC by 50 by root 3. So we can write BC equal to AB root 3. That is 50 by root 3 equal to AB root 3. Change the sides. We get AB root 3 equal to 50 by root 3. Take this root 3 to right side. We get AB equal to 50 by root 3 into root 3. That is AB equal to 50 by 3. By dividing 50 by 3, we get 16.666 etc. That is AB equal to 16.67. So AB is our building. So we can conclude, therefore, height of the building is 16.67 meter. A TV tower stands vertically on a bank of a canal. From a point on the other bank, directly opposite the tower, the angle of elevation of the top of the tower is 60 degree. From another point 20 meter away from this point, on the line joining this point to the foot of the tower, the angle of elevation of the top of the tower is 30 degree. Find the height of the tower and width of the canal. So here is given the figure in the question. Here this AB is our tower and BC is the canal. The tower is on the bank of the canal. From the other bank, a person is looking to the top of the tower at an angle of elevation of 60 degree. Then from another point 20 meter away from the first point, the person is looking to the top of the tower at an angle of elevation of 30 degree. The question is to find the height of the tower, that is AB, and also width of the canal, that is BC. First, let us draw the right triangles separately. The right triangles are triangle ABC with acute angle 60 degree. Here AB is the opposite side and BC is the adjacent side. Second right triangle is triangle ABD with acute angle 30 degree. Here AB is the opposite side and BD is the adjacent side. Let us take the ratio. In triangle ABC, tan theta equal to opposite side by adjacent side. First case, theta equal to 60 degree, opposite is AB, adjacent is BC. So, tan 60 degree equal to AB by BC. Tan 60 degree is root 3. So, we can write root 3 equal to AB by BC. Cross multiplying, we get BC root 3 equal to AB. Let it be there. Then, in second triangle, in triangle ABD, tan theta equal to opposite side by adjacent side. Second case, theta equal to 30 degree. Opposite side is AB, adjacent side is BD. Tan 30 degree equal to AB by BD. Tan 30 degree is 1 by root 3. So we get 1 by root 3 equal to AB by BD. Cross multiplying, we get BD equal to root 3 into AB. Now here we can see AB equal to BC root 3. So this AB we can replace by this value BC root 3. That is BD equal to root 3 into BC root 3. Root 3 into root 3 is 3. So we get BD equal to 3 BC. Now you see the figure. This total length is BD. So we can write BD equal to BC plus CD. BD equal to BC plus CD. So here this BD we can replace by BC plus CD. So we get BC plus CD equal to 3 BC. Now it is given CD equal to 20. So we can write BC plus 20 equal to 3 BC. This BC we can take to right side. We get 20 equal to 3 BC minus BC. That is 20 equal to 2 BC. Change the sides. We get 2 BC equal to 20. BC equal to 20 by 2. That is BC equal to 10 meter. BC is the width of the canal. So we can conclude, therefore, width of the canal is 10 meter. We need to find the height of the tower also, that is AB. Here we have AB equal to BC root 3. So we can write AB equal to BC root 3. Here we found the value of BC. It is 10. So we get AB equal to 10 root 3 meter. So we can conclude height of the tower is 10 root 3 meter. Two poles of equal heights are standing opposite each other on either side of the rod, which is 80 meter wide. From a point between them on the rod, the angles of elevation of the top of the poles are 60 degree and 30 degree respectively. Find the height of the poles and the distances of the point from the poles. So, first let us draw a figure based on this information. So, there is a rod with 80 meter width and there are two poles on the either side of the rod. The poles have equal height. Then it is given from a point between them on the rod, the angles of elevation on the top of the poles are 60 degree and 30 degree respectively. That means a point on the rod between the poles. Somewhere here on the rod, it is not the midpoint, you remember. So let us mark a point on the rod between the poles. So here I have marked a point on the rod. From this point, the person is looking to the top of the poles at the angle of elevation of 60 degree and 30 degree respectively. Let us mark it. So one angle of elevation is 60 degree and other angle of elevation is 30 degree. Let us give the name for the points. So I marked here A, B, C, D, E. Now we know the total length of BD is 80 meter. But we need this CD and BC separately. So let us give any one of them be X. So I gave this CD is X. Since CD is X, this BC we can write as 80 minus X because it is given the total is 80. Now let us draw the right triangles separately. The right triangles are triangle EDC with acute angle 60 degree and triangle ABC with acute angle 30 degree. The question is find the height of the poles and the distance of the point from the poles. So we need to find out the height of the poles, that is AB and TE. They are equal. Then again we need to find out CD and BC. Let us solve it. Consider the first right triangle EDC. Acute angle is 60 degree. This ED is the opposite side, CD is the adjacent side, that is X. Let us take the ratio there. In triangle EDC, tan theta equal to opposite side by adjacent side. Here theta equal to 60 degree. Opposite side is ED. Adjacent side is CD, that is X. Tan 60 degree equal to DE by CD, that is root 3 equal to DE by X. Cross multiplying we get X into root 3 equal to DE. If we take this root 3 to right side, we get X equal to DE divided by root 3. Now consider the second right triangle ABC with the acute angle 30 degree. AB is the opposite side and BC is the adjacent side. It is 80 minus X. Let us take the ratio. In triangle ABC, tan theta equal to opposite side by adjacent side. Here theta equal to 30 degree. Opposite side is AB, adjacent side is BC. Tan 30 degree equal to AB by BC. That is 1 by root 3 equal to AB by 80 minus X. Cross multiplying we get 80 minus X equal to AB into root 3. Now we have the value of X here, X equal to DE by root 3. Let us substitute it here. We get 80 minus DE by root 3 equal to AB root 3. Let us take this DE by root 3 to right side. Here it is negative. If we take into right side, it will become positive. So we get 80 equal to AB root 3 plus DE by root 3. Now we know this AB and DE, they are the poles. In the question it is given the poles have equal heights. Therefore this AB and DE are equal. So this DE we can replace by AB. So we get 80 equal to AB root 3 plus AB by root 3. Let us cross multiply here. We get 80 equal to AB root 3 into root 3 plus AB whole divided by root 3. This root 3 into root 3, it is 3. So we get 80 equal to 3AB plus AB whole divided by root 3. 3AB plus AB is 4AB. So we get 80 equal to 4AB divided by root 3. Let us change the sides. We get 4AB divided by root 3 equal to 80. AB equal to 80 into root 3 by 4. This divided by root 3 is taking to right side. It became into root 3. Here into 4. It became divided by 4. Now we can cancel this 80 and 4. We get 20. So we get AB equal to 20 root 3. Therefore, height of the pole is 20 root 3 meter. There is one more question, find the distances. That means we need to find out what is DC and what is BC. DC is x. BC is 80 minus x. Here we know what is x. X equal to DE by root 3. We have x equal to DE by root 3. DE is the height of the pole. We proved height of the pole is 20 root 3 meter. So, x equal to 20 root 3 divided by root 3. Root 3 and root 3 we can cancel and we get x equal to 20. So, we can conclude DC equal to 20 meter. Then BC. BC equal to 80 minus x. That is equal to 80 minus 20 equal to 60 meter. Therefore, the distances are 20 meter and 60 meter.